Hello everybody, welcome back to our Spring Boot series. Today I would like to talk about how Spring Boot creates our beans using dependency injection. And there are three strategies that we'll be talking about: constructor, setter, and field injections. First, let's look into what is dependency injection. Dependency injection is the design pattern to achieve loose coupling. Loose coupling means that if you have a system with two components, let's say A and B, and A depends on B, I can replace B with a C without changing nothing on the A. That's what I'm talking about when we are using loose coupling. For instance, I can replace one class for a testable class, or I can replace a database with a different database. Usually in class we can achieve this using interface, because the class A will access the class B through an interface. When I say interface, an abstract interface, a definition of interface where a class B implements that interface. Now, if you have a class C that implements the same interface, I can replace them, since the class A doesn't know nothing about implementation, only knows about the interface, which sometimes call it contract. That's one way to achieve loose coupling. In a microservice architecture or other kind of architectures, or even a common architecture, you can achieve loose coupling. For instance, when you are using JDBC, when you're using JDBC, you can exchange one database with another without changing your code. The only thing that we will have to change probably it's the driver on your Maven dependency or Gradle or something. Otherwise, it's not necessary to do nothing more than that. And the Spring Boot manages object creation and wiring automatically. That's what this dependency injection is about in Spring Boot. It promotes testability, readability, and maintainability. Of course, after the explanation, I think you should understand why at this moment, and Spring Boot can achieve this using three strategies: constructor, setter, and field, and it will be on our side to choose which one do we want for each one of the beans. We don't have to choose one as a configuration. It's how we provide specific annotations that will lead Spring Boot to understand which one to use. So how does Spring Boot performs injection? First, it starts uses the Spring context. It's an area inside Spring Boot where all the configurations beans are defined. And it does a component scan. Component scan belongs to the first step of the Spring Boot when it starts. So it will look into all the classes using reflection and say, okay, which ones contain annotations that I know that I should manage or I should handle in my Spring context. After it finds all those classes, you will start to see which ones are beans that should be handled as beans, because there are other annotations that are not bean related, maybe configurations and things like that, but some of them are beans. So he tried to discover beans. After he discovered all these beans, like REST control or service repositories and so on, he starts to create them. But some of them can have dependencies or not on other beans. When some of them contain some dependencies, it starts as the dependency resolution, meaning I cannot create my REST control if I don't have a service, and I cannot create my service without having a repository, and I cannot have a repository without having a data source. So I have to create a data source, inject on the repository, which injects on the service, and then injects on the REST controller. That's what is dependency resolution. Of course, when he defines this dependency resolution, meaning what is the relation and the direction of this dependency between the beans, which strategy should be used: constructor, setter, or field injection. So we can start with the constructor injection. It's the most popular one, and it's the one that we should use. And the way to do it is just create a constructor, and on the parameters we will have our beans, meaning that I can't create my service, or Spring Boot cannot create my service, and it's a bean because we have an annotation here. Otherwise, it's just a regular class. It will be ignored. Don't forget that. Okay, but as I was saying, okay, I can only create my service after I create my repository. That's what this strategy is about: constructor injection. Okay, advantages: it's immutable dependencies, because it's quite common when we are using constructor injection to put the private fields like my repository that we inject here as final. So it's the best approach. So by mistake, no one will change or set this field with a different value, putting in cows all the definitions that we created in our application. When using frameworks like Spring Boot, we want to clearly define the dependencies in using our configuration, using our annotations. So I want to make sure that they will not change during the execution. Okay, so the immutable, it's a good thing. Fail fast because it's a constructor. or you can construct or not. If you can construct, the application will never start. That's as simple as that. So it's a good thing. It's test friendly because we can replace here with a test class. I can use here an interface rather than a class, and it will try to find a class that it's implemented that interface. But if I am in a test environment, I will provide a class that is a testable class that implements the same interface as a bin. So Spring Boot will find my test bin and not the other one. And there exist ways when we are defining the test to say start here with the bin, my test bin. If the test bin exists, use this context. So this part here, this Spring context, you can have a Spring context for your application, but you can also have one for testing. And when you have one for testing, you can replace your bins with testable bins. Okay, and it's a clear contract, meaning that when we look into the code, we already know, okay, to create my service, I need these dependencies. Of course, there are some disadvantages, more boilerplate code. Why? Because here it's quite simple. We have one dependency, but it could be 10 dependencies. Maybe only 5 of them are required. The other ones sometimes are null. If they are there, they're great. If they are not, my application works anyway. Maybe some of them can only be initialized later, which can be a problem using constructor injection and can become less readable with too many constructors, as I was saying. Sometimes people work around this by using required R constructor, using frameworks like Lombok. I like Lombok in some scenarios. I don't use it too much when Spring Boot, because Spring Boot already generates code. Lombok generates code. Sometimes we have other frameworks that are generating code, and sometimes the issues can be quite crypt on the output. So I try to avoid them. But if you are comfortable using Lombok, great, kudos for you. Continue to use it. Use cases, service or components with required. For me, this is the word about the constructor injection. If you have required no null dependencies, that's the constructor. I mean that when you go to the constructor injection, you say, no, this instance should exist. I don't accept any null. So how do you define a constructor injection? There is no clear configuration. It's when you create a constructor like this one with a bin here, and Spring Boot looks into this class and say, okay, you have a constructor there. I understand this my repository is a bin, so I will call your constructor by default. Okay, that's of course if you have more than one constructor, you have to provide here the auto wire keyword. Otherwise, there will be an ambiguity, and Spring Boot will not know which constructor to call. When there is only one, it will call the default one. If there is more than one, you should provide auto wire keyword like this one. Now we have the setter injection. Setter injection is quite easy to understand. Imagine that you have the constructor injection, but now there are some let's say bins like my repository that should be delayed. Mean that you want to create the my service, and only after it is created, and only after the my repository is created, you want to call this set. Meaning you want to create this bin anyway, even if the my repository is not available. And sometimes it's called like you have optional dependencies. So they can be there or not. And I work with systems, legacy systems that connect to a lot of external systems in a bank. And some of the bins, sometimes they took 10 minutes or 20 minutes to be initialized, and some of them couldn't be initialized. But the application should start. Of course, the code should be more defensive. Every time you will be using this repository in your code, you should be careful to check if it's null or not. Maybe it was not yet initialized, or it was not even initialized. So be careful with that. But it's a workaround. Sometimes the constructor is too rigid to be used in some systems, and in legacy systems, maybe it's better the setter. And not only in legacy systems, maybe there are some dependencies that should be more, let's say, relaxed, taking into account the requirements of the application design. Okay, so advantage supports optional dependencies. I was saying it's readable. You just look into the set. Auto wire. By the way, this set is automatically called by Spring Boot. Yeah, I know it's a method, it's not a constructor, but since the Spring Boot understands that this is a component and there is an auto wire there, it will look for an opportunity to inject my repository. As soon as it gets an instance of my repository, it will call your set method. Okay, it's readable, it's more flexible because you can handle rigid and non-rigid ways for the bins to exist or not. Okay, disadvantage. Dependencies can be left unset, can be null. That's something that we were talking about. meaning that increase the risk of null pointer exception, and there are less obvious which dependencies are critical for the component. Yep, it just set. We don't know if this is a very important requirement or not. Contrary to what we see here, because it's in the constructor when you use constructor injection. So we know that this one is quite important because we cannot create my service without repository. Okay. So use case, beans with optional collaborators, configuration class or beans that require post-construction setup, something that I should talk about in other videos, that there are a method, it's the life cycle of a bean. We can call specific methods before and after a bean is created, for instance. Sometimes to clean up things, to initialize things before a bean is created. And the setter is quite good for these use cases. And when dealing with circular dependency, sometimes you have a class A that depends on the B, then depends on the C, and then for some reason someone wrote the C to depends on the A. And the application breaks on the constructor injection, but on a setter injection, that it will allow the cycle. It's not good practice, but sometimes it's necessary for some reason, because the setter, it will only be called after the creation. So everything is already created. Okay, you can just set it. It's not something good when an application has this kind of cycles, but we never know in legacy applications. Okay, but if you have a cycle and you don't know how to resolve, just stop using the constructor injection, use a setter injection, and that problem should disappear. But as an advice, check first why there is a cycle there. Okay, and later we have the field injection. It's not a good practice for production environments, but it's simple. It's really easy. You just put the auto wire of a field, and Spring Boot will look for instance of my repository, beans that are my repository, and will inject them here. If you can't find, just will be a null. So it has the problems of the setter and the problems of the constructor. Every problem it's here. So that's not very popular to use. At first it seemed a good idea, but it's not. Why? Harder to unit test because it's private. Yeah, you are injecting things directly on the private, so you are violating encapsulation. There are hidden dependencies not visible in the constructor or setters. It's somewhere in the fields. And if you are beans, inherit from beans for other classes, which is the good practice. But if that exists, it can be tricky to find all the issues, so it discourages it for production code. Okay, advantages. Minimal boilerplate. Yeah, it's just this. There is no set, no constructors, nothing. It's just, I have this field and it should be auto-wired. There is nothing. We don't need more code than that. Okay, and very concise and easy to write. Okay, use case, quick prototyping, small legacy code base. Sometimes the code is already like this, so we have to accept it as is and refactor it later. And when working with simple DEM projects or proof of concepts. Okay, so let's see just a summary of what we talk about. Let's see in a sequence diagram how Spring resolves dependencies. So we have the Spring context, and the first thing that it does is just scan all our beans. And it scans and detects REST controllers, scans again other packages, and finds service, finds a repository, and even finds data source. Most of the time these data sources are in property files, but can also be in Java code. Now he understands all the dependencies between them and understands that the repository depends on the data source, the service from the repository, and the REST control depends on the service. So he instantiates the data source and then injects the data source on the repository. After the repository is created, injects on the service, and after the service is created, can inject on the REST controller. That's how Spring Boot does things. It's quite simple. It's not more complicated than this. Of course, there are a lot of configurations that we can constrain and change a little bit the behavior of the Spring. We can delay the initialization of beans. It's called lazy initialization. There are a lot of things that we can put on the Spring Boot. It's not as simple as this one, but the core, the behavior, and the way you should think about Spring, it's what we talk about. This is the sequence, and there is constructor, setter, and field injection. And if you understand these simple concepts, everything in Spring Boot works like this. So we want to create something, try to create a bean. Now teach to Spring Boot how to initialize this bean. When should it be initialized? Who depends on this bean? And there are other things about scope that we didn't talk about yet, but that's the main core of the behavior of the Spring Boot. It's only this that we talk about during the last 10 minutes. Okay, so this is a most common application. So everything can be a bin within different packages, but at the end of the day, it just creates a tree like this one Okay, and the logic, it's always the same. This is the graph that is created by Spring at the context level. It's called bean dependency graph. And then you understand that to create this one, it needs to create the clock, data source, the logger, and then after it creates the logger, can create the connection manager, then can create the HTTP client, then the payment gateway. It's only after everything here is created, it can create these two instances, and after these two instances are created, it can create web controller. If we are using constructor injection, if we are using, for instance, field injection, usually the logic is the same, but if, for instance, one of these fails, it will be null. So, but it will be accepted, but it will be a null here. That's one of the drawbacks when we are not using constructor injection. So, best practice, prefer constructor injection for mandatory dependencies and immutability. Use setter injection when dealing with optional or late initialized dependencies, meaning that I want to allow the creation of the beans, but only later the dependency will be injected. Of course, there is the risk of not being injected and remain as null values. That's one of the risks when we choose to use setter injection. Avoid field injection in maintainable, testable code bases. Summary table, I just left it here. So type constructor setter field, when to use default for service, mandatory beans, setter optional beans, circular dependencies, when they happen, choose setter, prototype, small legacy code, and the pros and cons here, if you want to pause the video and read better, but it's just a summary of what we talk about during our latest minutes. Okay, so let's see an example in the code of our application. I cleaned a little bit my previous version of this application, but users REST control service and repository are still here. I just removed the lessons about the matrix, path variables, and things like that, because they're just for educational purpose. Now we are targeting again our main application. So we have our REST control. I'm using a constructor injection strategy, and there is no configuration here or the application properties about which strategy I'm using. There is nothing like that. Spring Boot understands that I'm using a constructor strategy because I have a constructor without a wire. Okay, since this is the only constructor, this is optional, but I think it's a good practice in case that you had, for instance, another constructor for testable purpose or something like that. Auto-wire, it's always a good idea. So, and I'm stating that I need the user service, and I inject here the user service, and I put here as a private, and I'm doing a system out here. So I need user service, so Spring Boot should create user service before creating REST controller, but to create the user service before the REST controller, you should create user repository, and to create user repository, you should create a data source. And you say, where is the data source? The data source is just an interface. The data source, it's here. So you can see the dynamics of the Spring Boot, and you can see here, it's our in-memory database, the H2, and you can see it's a data source. This is a different way to define beans, and there are a lot of them that you can define using just properties. Of course, internal, there will be an implementation of the class data source, and with a constructor that will receive all these parameters, but that will be done by Spring Boot. But can we create, if you are wondering, data source using Java code? Yes, you can, and you can have more than one bean data source and teach to Spring Boot which one to inject in this specific repository. But that is something that we'll talk in further lessons about when we have multiple beans of the same type, which one Spring Boot should choose in a specific place. Okay, that's possible using Spring Boot. But here it will be create the data source by Spring Boot. So it will create a repository. After the repository is created, our user service can be created, and after user service can be created, our REST control can be created, and this one will be called. So if I run this application at the start, this system out, I have system outs in all of these constructors. We should see them on the output in the different order than the call that we expect. Okay, let's start and see the output. And you can see that the first constructor, it's the repository, and only after this constructor, the user service was called, and then the REST controller was called, because REST controller needs the service and needs the service repository. And that's why we have the name dependency injection. So there is a dependency that will be injected, so dependency will be created first. But I want to show you the other one, because sometimes people wonder how the set like this one works. So I will comment this approach, and I'm changing now the strategy just for this bean. I don't have to choose a global strategy for all the beans, but the REST control in particular will use a setter strategy and not a constructor strategy. And the way to do it, just move the auto wire to a set. You can have multiple auto wires, by the way. You can have as many as you want in different methods if you have different dependencies to put you on the parameters. Okay, it's not one auto wire. You can have as many as you want. So in this case, this is a regular constructor. It is not Spring Boot will call this constructor because there is a REST control, but we do not call it as a dependency because I don't have any dependency here on the parameter. So you don't participate on the dependency, but there is a dependency that Spring Boot will detect, which is, okay, I saw that you have an auto hire here and you need a user service. So as soon as I have a user service instance, I will call this set. But of course, to call this set, I have to create an instance of this one. When will Spring Boot create this instance? As soon as possible, because there is no dependency from this bean to another one. So let's see, let's stop, clear this. Let's start now with the set and see what happens. So I have a system out here saying set user service. And let's see the sequence. Now we have this user repository. This was the first one that was created. And now we see that it created the REST controller because no one depends on the REST controller. So Spring Boot decided to create it as the second step. Now it created the user service. Now, because for the user service, there is the need for the user repository, and it already, so it can create user service. And why created now the user service? Because user REST, it detects there is a set here that needs the user service. And now after it created user service, it called automatically this set. It didn't create the bin. The bin was already created on the step 2. Okay, this constructor. It's only on the step 4, it was the latest one, that when it called the set. So a lot of things could have happened here in this constructor, nothing related with Spring Boot and dependency injection, maybe initializing systems, but the Spring Boot later, after it created user service, it said, okay, I have here an instance of user service. Who wants this instance? And the REST controller said, I want that instance. So call me the set user service and injected here our user service here. And now I can put this one here. It's not mandatory. This is one way. I can receive, for instance, a bin here that I don't want to set. I just want to call something and take the result and keep it in my bin. It's not mandatory that I have to, just because I receive here a bin that I want to store it locally on my bin. Maybe I'm only interested in call a specific method to load some data and I just want to keep the data, not because I will not need this bin anymore. Okay, don't try to create strict rules in Spring Boot. The only things that Spring Boot looks into, it's the annotations. What we do in the code, it's on us. Okay, that's what I want to talk about. This dependency injection and Spring Boot. Okay, I hope this was useful. I can assure you that this is one of the most important lessons that I can teach about Spring Boot, because this is how Spring Boot sees your application and your beans and how initialize them. Of course, there are a lot of different configurations that you can apply that can constrain or change a little bit the behavior of the Spring Boot, but at the end of the day, these are the three most core features of the Spring Boot: how he finds beans, how we create these beans, and in which order are they created, and with which strategy, constructor, setter, or field. And try to understand this lesson, repeat, go back and forth on the video, try to understand it, provide comments if you think I was not clear, maybe I can explain more deeply some of the concepts, give other examples. But from my experience, everything that I said here should be enough to understand. Of course, there will be other videos where we'll be applying this. And remember, just in case you forget, this particular example, after I change this to use the setter, we are working with, at the service level, with a constructor strategy, and the REST control with the setter strategy. So it's not exclusive. You can mix all of them depending on the use case of the specificities of your bin. So I hope you like this lesson. Please subscribe, tell your friends, share it. It it will be very appreciated, and I promise you that I will provide more videos about Spring Boot until I reach at least how you can create a big Spring Boot application with most modern technologies, including Dockers, configuration managers, load balancing, and so on. Everything is included in Spring Boot. One day I will reach there, but I will be providing videos until we reach that point. I'm starting from the beginning, as you already understood by now, and I will increment until you'll be an expert on this area. So hope to see you in my next video. Thank you for watching.